Hello and welcome back to module number 7. I'm going to take a little bit off scale with regard to the book, and I'm going to talk about distribution analysis and how we able to visualize it using visual analytics. And then I'm going to focus in this module on introduce you to the open source R or the RStudio and what does it entail. So let's begin. We are going to talk about distribution, what does it mean, and we are going to look at frequency distribution and their graph. We are going to talk about central tendency. Again, I know that it is related to statistics, but I want to focus on the idea of what is a variables 1 versus 2 or multiple variables, an example of R, open source R, with that regard. So, distribution. The distribution of statistical data set is a list of all possible values of the data and how they occur. So when a distribution of categorical data is organized, you can see the number of percentage of individuals in each group. So the dimension of distribution in visual display usually entail the shape, the location, and the spread. The shape is the show how the variation is distributed about the location. The location is expected value of the output being measured, and the spread is the spread amount of variation with the output. So the spread is expected amount of variation associated with the output. That tells us that the range of possible values that we would expect to see. A point of reference to the spread is the box plot and histogram, which means that this is where we use it most often. The spread, in comparison, is the spread of the data distribution possibility, and we have two types. The second type is the peak, where there's a single peak, double peak, and multiple peak. And again, this is the idea of how we're going to apply that into visual analytics. Location is another one. As you just note, I did not talk about symmetry because it seems to me it's trivial and does not tell us more about that. So the location is the third element, which is the value around which the process is being captured. It represents the numerical values of the mean and the median, and the location is best used with scatter plot, box plot, and histogram. So again, the scatter plot is a really good way for us to capture data. The problem with that is that sometimes people get lost, and I'm going to start talking, and in chapter 11 I'm going to talk about the design aspect more in the upcoming modules. I just want to have a better sense of, to give you a better sense of the statistics and how it match up with the visual. So the shape, again, tell us if our variation is systematic about the mean or it's fit for a multiple, and we have different shape of distribution, and each one of them represent better way to capture that. And again, the shape of distribution, and this is what we would probably see, the systematic, the skim to the right, to the left, and so on. The box plot are excellent tool for conveying location and variance of information in dataset, and particularly for detecting and illustrating location and the changes that might have to different groups of the data. And this is really good because I'll show you in open source R how can we color that in order for us to make our point stronger. Frequency distribution is another element that I need to talk, and again, the issue of the final project is come into play. And frequency distribution is the ability how many times this variable appear in the data set. A table that organizes data values into classes is usually falls into frequency. We have ungrounded frequency distribution and grounded frequency distribution. Each one of those distribution display it differently. So ungroup and group, and this is how we sort it out. And again, I want you to start thinking about your project and how you're going to do that with regard to distribution. So the frequency distribution or histogram is a well-known way for us to capture frequency distribution. A bar graph represents the frequency distribution or histogram, and then it's we have two scales. Usually the frequency is the horizontal scale, and the dagger value is on the X scale, and this is something that is usually displayed in academic journals. So frequency and its play out and how to relate it. Again, relative frequency distribution show the proportion of or percentage of the data that falls into a particular class. So we are talking about class frequency divided by the sample size, and a sample size can be the entire population. It doesn't really matter. But in this case, this is how we allow us to do that. The relative frequency histogram has the same shape and the same scale as the corresponding frequency histogram. So again, the frequency where it is and how it's laid out for us give us a sense that the frequency is usually on the Y scale, and that's how we allowed us to display that. Group frequency distribution, again, the way for us to sort it out and how to do that. Lower class limits, upper class limits, class width, all those things has to come into play when you are going to start thinking about your data set. And I will talk more again in the upcoming module. I'll talk more about the final project and a data set. Some of you already started to ask me questions. So example, with regard to back to our subject, the frequency, class midpoints, class boundaries are important part of descriptive statistics. And again, this is something that we talked about, and we talked about that with regard to distribution. So the central distribution, again, something that we always learn in statistical textbooks about that, the mode, the mean, the median, the mode, and how it's been used to display it. In this case, again, we are talking about the bar chart and not histogram, but bar chart that allowed us to show more than one set of, allowed us to show most frequency set of data. Binomial or two peaks distribution is also very common in visual analytics. And in this case, score number 1 and score number 2. And again, this is something that I want you to remember that you can apply, and the bar chart is a good way to do that. What about multi-dimensional that has more than two distribution of data? And again, we can do that, and again, it's allowed us to apply that, and it's something that we need to think as a designers how to apply that and how to do that. When you use the mode is not very useful to measure central tendency. So it is insensitive, and be careful when you use it, and just be concerned about what is it entail, and again, with regard to statistics and how is it done. One of my favorite visual, probably I show that image again and again, and about bakery, what type of cookies you like best, thin mints or shortbread, or even peanut butter and chocolate, and all those things is a good representation. But again, the issue is, does it represent more than one data set, and what type of distribution it tells? It is something that we need to start thinking about in that regard. A single variable visualization, histogram, is a good way to represent that. And histogram shows centers. She shows the extensions, if there is external values that is not usually captured in pie chart, and it shows us modality, which is also so outliers and strange usually display quite well in histogram. And be aware of real zero, because sometimes you will lose the vision of the histogram. The issue with regard to the histogram is, for small data sets, histogram can be misleading, and I want you to take it in hand and remember that small changes in the data will not be detected by by someone else. And so this is something very important. For a large data set, histogram can be quite efficient if everything is being displayed. And again, what will happen if your big or large data set does not have has a lot of zero? How can it be displayed? So again, this is something that you need to consider with that regard. So, but be careful with the axis and the scales and how to apply that. The scale is that you just focus on one aspect of it and apply that, and appreciate that what it brings into the visualization. Another way for us to apply the histogram is density estimates. And it has a formula, and it applied to it, and it allowed us to estimate the smooth out of the contribution of the data point of a local neighborhood of that point. So it gives us some dimension. And again, I'm looking for more in-depth into the visualization to give us more attribute to it, and what does it entail. So again, in this example, we're using another dimension, another statistical dimension, to give more depth to our analysis, to give more interest to our visualization. Okay, so now to the main subject of our module, and this is the introduction to R and the RStudio. What is R? R is a software package for statistical computing and graphic. It has more than 6,700 packages. What does it mean? I wrote 3 packages. Some other people wrote more than that. So every year we have a conference where we present our packages and allow other people to use our packages. Everything is free in the R. We do not have to pay. Some of you probably will run into problems when you are using other software we covered in class. My obsession, my passion with the R is that it is always free. Yes, you will need to do some extra work, which is the writing of the code, but in the end of the day, it will be worth the investment. So it is a programming language. It is under a working environment. It's widely used. It is very powerful, and it's free. If I had the animation, probably the word free will pop up again and again. So, example of visualization that the R can do that other software cannot do. And in this case, it's part of my book, and how it has been the number of R packages since from 2002 to 2014, and the number is growing very fast. Let me show you other example of distribution of the power of the R visualization and the ggplot2, which is a package that you can download for free, and I will show you next time. I'll show you how to do that. And again, look at the power and the colors that this platform allows you to do, and see it. I will share those links with you so you will be able to experience firsthand on the power of it and how it's been applied. And this is just the beginning. There's many more examples and how we can apply to it. And again, this is what my love is. This is where my passion. If you have Pinterest, there is a data visualization and Pinterest group that use open source R, and this is the work that I usually follow. I am a very active member in Pinterest, and this is something that, again, something that can be done in R, and just think about that in your terms, that you are able to do that. There's many more examples of the R, and again, this is something that I want you to become involved with and be able to apply. So I need to talk about a little bit history, because R is not a new software. Before R, there was the S, which was developed in Bell Labs in the 1970s. But during that time, in late 80s, Bell Labs was sold to AT&T, and as a result, the S program was dissolved and never was developed. The miracle that happened was created in 1990s, when two two researchers, Ross Iker and Robert Geldman from the University of Australia, started to write the S as R, and they decided that why did they call it R? Because R is the first name, Ross and Robert, and as a result, they converted it to the R. So this is part of the galleries. Our gallery is part of it. I'll share it also in the Canvas pages about the R and what does it entail. And again, this is a very powerful tool. So we talked about distribution today. So test performance by gender. And again, you can play it or test it in different platforms. And again, this is quite powerful. An example of graphings, I can do it in one graph. I can have city, food, decor, and I can have a bar chart, I can have line graph, I can have a point graph. I can do it all in the R, something that other software application that we cover in class does not allow us to do. So who uses R? Usually people with IBM SPSS distribution, but also other people. And again, this is the tool that I can allow myself into 2-dimension or 3-dimension, something that other software do not allow us to do. And this is part of my work that I did in R. And again, see the many variables that I was able to embed it into the R in order for me to display it. So the R Studio, it is a working environment. It is usually easy to use than the R, the platform that they established in 1990s, and it is a product that runs on a server and a client, but it is free for all. So you can download the application to your desktop, and when you do that, you will get a screenshot like that. This is the interface. If I will open my interface, this is what I will cover today. And again, this is the code, this is the console, this is the visualization. This is where I'm going to search for packages that will allow me to create more application or more ability in in compared to any other application. So we are going to learn today, and this is the RStudio website. I want you to visit it, and if you can download the RStudio for yourself, that will be free. We will learn about Shiny for one module in the end of the class, in the end of the semester. But again, one of the things that they are doing right now, the people in the RStudio doing, is trying to bring it into the web. It costs money, but it is something that is really important. So R provides us basic visualization function without any packages. I'll show you a simple example. This is the code that you're going to, it's quite easy to copy it as it is. You don't need the marks, but you're going to need, in this example, you will copy, open a new script, you will copy this for my PowerPoint presentation. And I will produce that. I'm just going to show you so I don't need anything else. And one of the things that you're going to learn is that the R, in compared to any other program, you need to run line by line. So line by one. Something happened. He will tell me something happened. Okay, so let's see if it will run. Okay, now it ran. And the next one is good. I'm going to say, show me what is the container or the data set inside. And now I'm going to ask him to generate for me a pie. So pie and the name of the data set or the container that holds these values. And I'll say run, and this is what it will come. This is basic. This is 101. If I will again run the code from my PowerPoint presentation, and you don't need to use, so in this case, okay, so now I'm going to add the colors, and you can change the colors: red, blue, green, and black. I don't know why I chose them, but I did. And I'm going to run, and I'm going to add my colors. So in this case, I'm telling the R or the RStudio to run it based on my preferences in compared to what I said to him. Use whatever you have in stock. So in this case, it will change, and as a result, I will be able to customize my visualization. So this is very basic. And same thing can go with the bar chart. And again, bar chart, if you look at the code, I said create the same container that I use, display it as bar plot. This is what will come, and I can change it again, names. I can change, enter the set, and I can bring it together in order for me to display this. In this case, I use my colors, and I use my colors as my give it a title and the colors itself in order for me to do that. A simple histogram, I'm using histogram is the code for histogram. So it's and I'm using a data set that already embedded into the RStudio, which is called mtcars, and I'm doing it with $sign and with regard to MPG, which is again the frequency or the number of distribution. So in this case, it will display to me that way. I can have it as a break with regard to the distribution of, in this case, I have 12 breaks, and I have the ability to add colors to it. So again, adding the curve, I can add to it, and I can build much more. And again, box plot, I can do that. Time series, I can do it. And again, you will get for me a lot of example with regard to how to apply. Example, continuous variables, how to do scatter plots with that, how to do no parent relationship, with linear relationship, other type of relationship. And again, this is part of the statistical and analytical with the visualization, and this is what the power of R with that regard. So this is just to make your eyes look, I want to do that, and that's the point that I'm trying to do, and I hope that you will catch up why the R is so powerful with regard to the way it display itself, the way it organize. I can have, again, one of the things that was really hard for the application that we saw or experienced with regard to multivariance analysis, more than two variables. This is where R is the king. This is where it allowed us to do more and more and more. And again, this is how powerful it is and how it provides. So again, I'll show you example of iris data and what does it entail, and you will be able to do things like that, which is with alpha blending that can be effective with regard to the visualization, and add colors to it to make it much more. Network is also part of it, and again, I wanted to catch your eyes. So what are we missing? One of the things that we talked about that, and I know that I did, but I saw some of your work, and I want just to make sure that my points make sense to you. With regard to the pie chart, some of you already took it as your default settings. It is very popular. However, it is really hard to understand if you have multiple variables inside those pie, and something that is less coherent when you have so much variables go on. So human perception is not good in comparison using the pie chart, and this is a scientific fact. So bar plot, histogram usually better and less, but it's less prettier, and I understand. The 3D is also, I saw some of you already using the 3D. It's nice. It's able to display 3D, but it's hard to do it well. And it is usually you are losing sight of what we are trying to achieve. And again, not. One of the things that we like to show is the worst graphic in the world. This last week, I was in, it's called the largest conference in visualization. It's called IEEE Viz, and it happened last week at Phoenix, Arizona. I will post some of the work that I have seen, and I'll show you one of the part of what I'm doing with regard to peer review. So in the upcoming class, we will start doing peer review. In that case is my work that I am involved. But back to our subject, worst graphic in the world, and this is bad graphics. And to the left, to the right, you will see the 3D, or to the bottom, you will see the 3D does not always work so well. And when you have multiple dimensions, sometimes again it is hard to understand. The idea of dimensions reduction is really important, and the dimension of how to do that is also. One of the things that I want to talk about is the Hans Rosling. He is a Swedish researcher that dealt with the population wealth and examined the wealth in all around the world. He uses this video, and I want you to see that, to display what happened through the years and in the future, and why is it happening. I want you to look at the visualization aspect. This is important to me because Hans Rosling died this year, and one of the things that he talked about very, very with passion was the visualization. How can you make your visualization more transparent to other people? I'm going to finish my my lecture today about best practices. Try to make it scalable, try to make it consistent, try to measure that they are resistant to outlier. Outlier is a really hard sell, and it's sometimes people do not understand it, and we see that quite often with big data. That is, we lose the point. So this is things that I want you to keep in mind. Keep interval consistent. First rule, the size of the interval along the category scale is that it must be equal. Make it consistent. Try to establish your consistency with regard to your example. Example from the book, in this case, how to apply that. Based on our textbook, the top histogram is only one with consistent size age interval. The second histogram ends with 20 age groups, but 10 years in the middle. The third has some exploring around of the ages. So what do you think is the best way to present this data in order to keep the interval consistent with overall selecting? So again, the issue of how do we display it, how to do that, and to take the outlier out of the display itself. That is all. If you have any questions, let me know. In this module, you are going to be introduced to Ask, that you will evaluate your peer review. I will give you an outline of what the peer review consists of. You will do that. We will use the Canvas platform for that, and the next time we will use it, we will use my development with my review about visual peer review. But for now, we are going to use Canvas, and please let me know if it works well and makes sense. Until next time, I hope you enjoy that, and until next time, have fun.